Today, we're going to talk about arithmetic and geometric sequences. An arithmetic sequence is a sequence created by addition. Now keep in mind that you could be going down in the sequence also because you could be adding a negative. Either way, you're adding the same number over and over and over as I move to each new term in the sequence. That difference, the number I add each time, is called the common difference. Look at the sequence here. Notice that 8 minus 3 is 5, 13 minus 8 is 5, 18 minus 13 is 5. 5 is what I add to get to each new term. That is called the common difference because each time I subtract the next term and the previous term, I get 5. We use subscript to describe each term in the sequence. The first term I could call a sub 1, meaning it's the first term in the sequence. This is not like an exponent. This lowercase 1 refers to the first number in the sequence. A sub 2 is 8, a sub 3 is 13, a sub 4 is 14, and so on. And eventually, sequence might end, and I could call that number a sub n, or it might continue forever. Here are two sequences. In the first sequence, my common difference is 4. I'm adding 4 each time to get to the next term. What you'll be asked to do sometimes is find a particular number in the sequence. What would a sub 22 be? A sub 22, to find it, you would start with 5. Every time you move forward one spot in the sequence, you add 4. Keep in mind, this is the very first term in the sequence. To get to the 22nd, I only have to move 21 places. It's always one less. So I have to add 4 21 times to get to the 22nd term because I'm starting at the first term. Put that in the calculator, and we discover that a sub 22, the 22nd term, is 89. The sequence below is decreasing, meaning I'm adding a negative. I'm adding negative 3. Or I can look at it as subtracting 3 each time. Notice that above we took 9 minus 5 to get 4, 13 minus 9 to get 4, 17 minus 13 to get 4. In this sequence, it's 97 minus 100, that's negative 3. 94 minus 97 is negative 3. 91 minus 94 is negative 3. Each time I move, I subtract 3, or add negative 3. To find the 42nd term, a sub 42, I start at 100. Every time I move forward one spot in the sequence, I take away 3. Because this is the first term, to get to the 42nd term, I only have to subtract 3 41 times. If I move 41 spots in the sequence from the first term, I'll get to the 42nd term. Enter that in the calculator and you get negative 23. The 42nd term in this list would be negative 23. An arithmetic sequence is created by addition. A geometric sequence is created by multiplication. Look at the example sequence below. From 3 to 6, I multiply by 2. From 6 to 12, I multiply by 2. 12 to 24, keep multiplying by 2. Every time I move one position, I multiply by 2. That 2 is called the common ratio. Notice that 6 divided by 3 is 2. That 12 divided by 6 is 2. 24 divided by 12 is 2. When I take the current term and divide it by the previous term, I get that common ratio. This is very important in understanding a geometric sequence, and it leads to exponential functions, which we'll talk about soon. Just keep in mind that a geometric sequence is created by multiplication, and to find out what you multiply by, you take any term and divide it by the previous term. Take the current term, like 96, divide it by the previous term, 48, and you're always going to get 2 in this example here. In the same way we do with arithmetic sequences, we can number our terms, a sub 1, a sub 2, a sub 3. A sub 6 means that 96 is the 6th term in the sequence. And I could talk about any term in the sequence and call it a sub n, and that would be the nth position in the sequence. If our sequence is decreasing, that means we're multiplying by a fraction. I could have a sequence where I multiply by half each time. In that case, each term would be half of the previous term. Here are two geometric sequences. Let's find the 10th term in the first and the 7th term in the second. First thing we need is the common ratio. Take the current and divide it by the previous. 15 divided by 5 is 3. 45 divided by 15 is 3. 135 divided by 45 is also 3. Each time I move, I multiply over and over by 3. To get the 10th term then, we would start at 5. Every time we move one spot, we multiply by 3. Because I'm starting at the first term, this is the first, to get to the 10th term, I only have to move 9 places in the sequence. 9 places from the first term gets me to the 10th term. This is going to be a large number. 98,415 is what we get. In the second sequence, notice the common ratio, current divided by previous, that 400 divided by 800 is a half. That 200 divided by 400, every time I take a current term and divide it by the previous term, I get 1/2. To get the 7th term then, a sub 7, I start at 800, I multiply by a half over and over and over, and to get to the 7th term, because I'm starting at the first term, I only have to move forward 6 places in the sequence. Multiply by a half 6 times. I put that in the calculator and I got 12.5. The 6th term in the sequence would be 12.5. The rest of this video is questions from your assignment. Question 1. Which of the following is an arithmetic sequence? Arithmetic means you're adding the same number over and over and over. You could add a negative, so it could be decreasing. So look for constant change. 67, 69, 65. Looks like we're going down 2 everywhere. This must be the one. To glance at the others, though, notice how that from -8 to 0, that's going up 8. I'm not going up 8 there. That's out. 182 to 183 is going up 1. 183 to 246, that's not 1. This one's out. 192 to 191 is adding 1, but then I don't add 1 to get to the next term there. The only one it could be then is the third one here. Here's an arithmetic sequence. Every time we move to the next spot, we're adding 4. The next term then would be 24. Question 5, looks like we're adding a negative. We're adding -4 or decreasing by 4 every time we move one spot. So after -5, we would have -9. Question 7. Here's an equation that produces an arithmetic sequence. Linear equations always produce an arithmetic sequence. The y values are always changing by a constant. If we want to know what a sub 9 is, that would be 4 times 9 plus 5. That's 36 plus 5, which is 41. A sub 10 would be 4, and you're going to plug in 10 for your variable. 4 times 10 plus 5. That's 40 plus 5, or 45. Question 10. We're asked to find the 34th term. That's a sub 34. This sequence begins at negative 76. Each time I move one spot, I decrease by 3, or add negative 3. So I take away 3 to get to the next spot. I take away 3 over and over and over. To get to the 34th term from the first term, I only have to move 33 places. I have to subtract 3 33 times to get to the 34th term because I'm starting at the first term. Putting that in the calculator, we get negative 175. The 34th term in this list would be negative 175. Question 14. We're looking for the 23rd term in each of these lists. First thing you have to do is find the common difference. From 3 to 1, we decrease by 2. From 1 to negative 1, we decrease by 2. This sequence starts at 3. Every time you move one spot, you take away 2. Because we're starting at the first term, we only have to take away 2 22 times to get to the 23rd term. That ends up being negative 41. For the second one, we're increasing by 3. We add 3 each time, from negative 9 to negative 6, from negative 6 to negative 3. We're starting at negative 9. We add 3 over and over. To get to the 23rd term from the first term, we have to add 3 22 times. That's 66 plus negative 9, which is 57. For the third one, we're increasing by 4. Add 4 each time. We're starting at 5, the first term. We add 4 each time we move one spot. To get to the 23rd spot from the first, we have to add 4 22 times. That's 88 plus 5, which is 93. And the last one, we're decreasing by 3 each time we move one spot. We're starting at 6. We're going to decrease by 3. And from the first spot, we have to move 22 spots to get to the 23rd spot. So 6 minus 3 times 23 is negative 63. Question 15 is about geometric sequences. Remember, a geometric sequence is created by multiplication. A real important thing to understand is what the common ratio is. That's how we get from one term to the next. We're multiplying by the same number over and over. It's the common ratio. The word ratio means fraction. We take the current and divide it by the previous in the sequence to find the common ratio. In this one, we take negative 54 and divide it by negative 6. I can pick any pair. If I take and divide the current one by the previous one, I get the same value. Here it's 9. I'm multiplying by 9 every time I move one spot. For the second one, I'll take a current value, 28, and divide it by the previous value, 4. And I see that every time I move one spot in the sequence, I'm multiplying by 7. 7 is the common ratio. For the third one, take any value, about 160, divide it by the previous, 40, and I get 4. Every time I move one spot, I multiply by 4. And for the last one, take a current value and divide it by a previous value. 18 divided by 3, for example, is 6. Every time I move one spot, I multiply by 6. 6 is the common ratio. Question 17, question about the geometric sequence created by multiplication. That's what makes it a geometric sequence. It's real important we know that the common ratio is the current divided by the previous. To be geometric sequence, anytime I grab a value and divide it by the previous, I should get the same number every time. And that's what I multiply as I go to the next spot. -6 to -8 to -10, this appears to be arithmetic because we are decreasing by 2 each time. That's not geometric. 3, 5, 7, 9, again, we're increasing by 2. That's arithmetic, not geometric. The last one, 3, 5, 8, 11, you're increasing by 2 and then by 3. That's not multiplication. That's out. It looks like it's got to be this one. If I take 64 times a half, I get 32. If I take 32 times a half, I get 16. If I take 16 times a half, I get 8. I'm multiplying by 8. The common ratio, current divided by previous, like 8 divided by 16, is a half. A half is what I multiply by. That's a geometric sequence. Question 19. Find the next term in the geometric sequence. We know that it's created by multiplication. I'm multiplying by the same number every time, and that number is the common ratio. If I take a current value like 80 and divide it by a previous value 40, I get 2. 40 divided by 20, 2. 20 divided by 10, 2. And 10 divided by 5 is also 2. I'm multiplying by 2 each time. So keep multiplying by 2. That means after 80, we'll have 160. Question 20. Another geometric sequence created by multiplication. First thing we need to find is how we get to each successive term. We multiply by the common ratio. We can find that by taking the current divided by the previous. Notice that -20 divided by the previous 80 is -0.25. I could also write that as -1/4. If I take 80 and divide it by the previous, -320, I also get -0.25 or -1/4. If I take -320 and divide it by 1,280, that's also -0.25. And the same thing for 1,280 divided by -5120, -0.25. Every time I move one spot, I'm multiplying by -0.25. So take 20, actually -20, and multiply it by -0.25 or -1/4, and we get +5. +5 is the next value in that sequence. Question 22. Another geometric sequence, we're going to find a sub 11, the 11th term. The thing about a geometric sequence is the numbers get very large very quickly. So we're not going to go too far up the sequence because the numbers are huge. First thing we need to find is the common ratio. To find that, we take the current divided by the previous. 320 divided by 40 is 8, and 40 divided by 5 is also 8. I'm multiplying by 8 every time I move one position. This sequence starts at 5. Every time we move one spot, we multiply by 8. 5 is the very first number in that list. To get to the next number, we multiply by 8. Because we're starting at the very first, we only have to multiply by 8 10 times. That's 8 to the 10th power. Check that out. It's 5,368,709,120. Big number. Question 24. We need to find that common ratio. Take the current divided by the previous. 64 divided by 16 is 4, as is 16 divided by 4, 4. So every time I move one spot, I'm multiplying by 4. To get to the 11th term, a sub 11, I start at 4. I'm multiplying by 4 every time I move. To get to the 11th spot from the first, I only have to multiply by 4 10 times. That's 4 to the power of 10. That is 4194304. 4,194,304. Question 26. Common ratio is 5. We're going to find the next term. The next term would be 4 times 5. 5 is what I multiply by to get the next number in the list. So my list would start at 4, multiply by 5, it'd be 20, multiply by 5, it'd be 100, multiply by 5, it'd be 500, and times 5 again is 2,500. So understand, this is 4 times 5, 20. This is 4 times 5 times 5, which is 100. This is 4 times 5 times 5 times 5. That's 500. And the last one will have 4 5s. That would be 2,500. Question 29. Let's find the common ratio for each first. Negative 8 to negative 16. This is the first one. We'll take the current divided by the previous, negative 16 divided by negative 8, and I get 2. Every time I move one spot, I multiply by 2. For the second one, I'll take the current divided by the previous, that's 27 divided by 9, and I get 3. When I move one spot, I multiply by 3. For the third one, take the current divided by the previous, 20 divided by 4, I get 5. So multiplying by 5 gets us to the next spot. And for the last one, I'll take the current divided by the previous, negative 28 divided by negative 7, and I get 4. Every time you move one spot, you multiply by 4. Now let's find the 7th term. For the first sequence, it starts at negative 8. I'm going to multiply by 2. Because this is the first term, I only have to multiply by 2 6 times. I get negative 512. For the next one, I'm starting at 9, and I multiply by 3 to get to the next value. I'm starting at the first, so I only have to move 6 places to get to the 7th. And that's 6,561. For the third one, I'm starting at 4, and I'm going to multiply by 5. To get to the 7th term from the very first term in the list, that's a movement of 6 places. 4 times 5 to the power of 6 is 62,500. And the last one, I'm starting at negative 7, and I'm multiplying by 4. And from the first term, I do 6 multiplications to get to the 7th term. Negative 7 times 4 to the power of 6 is negative 28,672.